Hi, I'm Radek, I'm a developer advocate at Ceramic, and today we'll be exploring some of the powerful new features in Ceramic and ComposeDB. These features give you fine-grained control over data relationships and indexing. We'll cover set relations, immutable fields, and the ShouldIndex flag. With these new features, you'll now be able to create unique data relationships between models, protect critical data fields from unintended changes, and selectively manage the visibility and indexing of your data for optimal performance and control. Ready? Let's go! First up, let's talk about set relations. This is a new relationship type in Ceramic that allows you to enforce unique constraints between models. And by the way, the name may be misleading a little bit. It's not a verb, it's a noun. We are not setting anything. We are working with a set, where a set is a unique list concept. First, let's see an official but rather complex definition. So with a set relation, each user or data decentralized identifier can only create one instance of a model for a particular record of another model. However, users can still create multiple instances of the first model for each instance of the associated model, as long as there is only one record per relation. It's a mouthful, but it's much easier to explain with a concept. So let's say you're building a decentralized image sharing platform. You want users to be able to mark images as favorites, but with one constraint: one favorite per image. You cannot favorite the image more than one time, it doesn't make sense. And that's where set relations come in. They enforce a unique list rule between data models. What it really means is that you can only favorite an image once, but you can favorite multiple images. So you can favorite image A, B, and C, but all of them only once, not more. Okay, so now let's see how to set it up in code. First, we'll have a look at Ceramic and then ComposeDB. So in Ceramic, in your model definition, you set a count relation type to set. And then in the fields array, you specify the fields that define the unique relation. So let's consider a real-life example of a social media app where users can like posts. We want to enforce that each user can only like a post once, but they can like multiple different posts. In this example, we have two models, post and like. The post model represents a social media post and has fields for content and author, and it uses a regular list account relation here. The like model represents a user liking a post. It has fields for post ID and user ID, and the important part is the account relation field here, where we are setting the type to set and defining the fields of that set. This enforces the constraint that each user can only create one like record for a particular post record. And with this setup, a user can like multiple different posts, creating multiple like records with different post IDs. But for each post ID, a user can only have one associated like record, preventing them from liking the same post multiple times. In ComposeDB, you'll do this during model creation. First, you set a count relation to set, and then you will use the count relation fields to define the unique relation fields. The fields must be included in the model, marked as the required, and be a scalar type. So for example, here with a given picture model, we are creating a new one, a favorite model with account relation set and the account relation fields being docID. Next, let's have a look at immutable fields. Sometimes you need your data to be rock solid and unchangeable. That's where immutable fields come in. Think of them as write-once values within your data models. You can designate certain model fields as read-only, preventing them from being changed after initial creation. How does it look in code? In Ceramic, when defining a model, add an immutable fields array, listing the fields you want to make immutable. And the type of fields that can be made immutable are scalars, arrays, or reference types. In ComposeDB, just use the immutable directive for any field in your GraphQL model definition, and this constraint is also inherited by models implementing an interface with immutable fields. Finally, we have the ShouldIndex flag for controlling stream indexing. By setting this Boolean metadata flag, you can include or exclude a stream from indexing operations. From the end user's perspective, this is similar to placing the data in a deleted state. However, it's important to know that the data is not deleted. It's just excluded from indexing, but it's still present at Ceramic network layer. And if you change your mind in the future, you can set ShouldIndex flag back to true to reindex data. And the way to do it in code is in Ceramic, you can unindex a stream by using the ShouldIndex false method on a model instance document. Reindexing is as simple as calling it again with true, and the default for ShouldIndex is true, and you only set it to false to the index. In ComposeDB, you have several ways to manage indexing, and the first one is to include ShouldIndex option in mutation and setting up in options ShouldIndex false. The second way is to use a mutation type called enable indexing, which should be paired with the model's name. So enable indexing post, for example, and then send stream ID and ShouldIndex value as part of the input. And the last way, when using the ComposeDB loader package, you can use the only indexed option like this. So to quickly sum it up, set relations let you enforce unique constraints, immutable fields protect key data from changes, and ShouldIndex flag gives you control over indexing and gives you kind of a way of deleting data without actually deleting it. With these features, you can now build more efficient data models for your applications. Check out the documentation for more details and examples. Thanks for watching and happy coding!